Okay, number one, whenever you have to match an equation with a graph, here's what I would do first. I would look out here to the right outside of parentheses in order to identify what is your vertical change. Whatever your vertical change is, that's also going to be your midline. That's where your graph is going to be symmetrical. There is no number out here. So then our midline is going to be at 0. So our graph should be symmetrical at y equals 0. So we can go ahead and eliminate that one and that one. This one's symmetrical at 0. This one is symmetrical at 0. Okay, let's see if we can narrow it down to, looks like they're both cosine waves. So let's figure out which one appears to be shifted right, pi over 4 radians. Now, cosine begins here, right? Begins right, oops, sorry, got distracted. Cosine begins right there. So which one of these graphs appears to be that little bump right there appears to be shifted right from the y-axis? This one. Your answer is C. Example 2, find the amplitude of the function. Amplitude is going to be that number in front of your trig value. Remember, it will always be positive. You take the absolute value of the number in front of your trig value, your trig function, sorry. So 2. Next, what is the period of the function? Well, this one is a bit weird. In order to figure out what the period is, we'd have to distribute pi over 3 to the x. Now, any number that's in front of x, that is your b value. And to find a new period, you have to do 2 pi over b. So we would be doing 2 pi over pi over 3. Remember, that's the same thing as 2 pi divided by pi over 3, which is the same thing as keep, change, flip. We want to keep 2 pi, change from division to multiplication, and flip pi over 3 to 3 over pi. Now, look what we can do. We can cross cancel these pi's and then multiply the 2 and the 3 to get 6. So our new period is 6. What is the vertical translation of the function? Well, we look out here to the right of the parentheses. There is nothing there. So there is no vertical translation. What is the phase shift of the function? We want to look inside parentheses. Don't distribute. It's already fully factored, so don't distribute. Our phase shift here would be right 1/5. Remember, it's always opposite of what you think it would be. This is 1/5 to the right. That takes care of example 2. Write the equation of a sine function that has the given characteristics. Sine function. Amplitude of 3. The amplitude goes in front of your trig function. Period of 4. Listen, if it tells you what the period is, then what you have to do is you have to take that formula in order to find a new period and set it equal to the period. So our period is 4, so I need to do 2 pi over b and set it equal to 4 over 1. Cross multiply. 2 pi times 1 is equal to 4 times b. And now we can get b all by itself by dividing, which would be 1/2 pi is equal to b. So this is going to be the number that goes in front of our x value. It looks like that'd be example C. Find the exact value of the expression inverse cosine of -√2 over 2. Create some room. Okay, in order to find inverse cosine, we have to use our arc cosine cheat sheet, which is right here. We need to find what is the cosine value? Where do we have a cosine value of -√2 over 2? And that would be right there. That occurs at 135 degrees or 3 pi over 4 radians, depending on how it wants you to answer. and it looks like radians. So D would be your answer. Okay, 5, we have cosine of inverse sine of 1/2. Remember PEMDAS, you want to do parentheses first. So we first want to figure out what is the inverse sine of 1/2. So now we're going to have to use our arc sine cheat sheet. We're looking for, where is our sine value? 1/2. There it is. That's at pi/6 radians. So everything inside parentheses here simplifies to pi/6. Cosine pi/6. Now we need to solve this. Where is our cosine value? Pi/6. A regular unit circle now. Here's pi/6. Our cosine value is √3/2. That's your final answer. C. Example 6, without graphing the function, determine its amplitude or period as requested. Find the period of the function cosine of 5x. In order to find a new period, that formula is 2 pi over b. In this case, our b value is 5. Your b value is going to be that number in front of x. So we just substitute 2 pi over 5. We cannot simplify. There's your answer. 7. I'm not going to read all that. Okay, so we have f of -1 of g of 5 pi/3. So I'm going to figure out what is the g function? Not there, there. There's our g function. So everywhere I see a g, I'm going to write cosine and then substitute for x whatever is in parentheses. So cosine 5 pi/3. Remember, PEMDAS, parentheses. We gotta do parentheses first, and yes, we have multiple parentheses here, so that means you got to solve the parentheses inside the parentheses first. So let's worry about cosine of 5 pi/3. Cosine means we're going to use regular unit circle. 5 pi/3 is right here. That cosine value is 1/2. So cosine of 5 pi/3, that's 1/2. And now we can take care of that f of -1. Let's see, the f function is sine, but we need to do inverse sine. So inverse sine of 1/2. So make sure you grab your arc sine cheat sheet. Figure out where is our sine value 1/2. There it is. And what are the radians at that point? Pi/6. There it is. Example 8. Find the exact value of the expression inverse cosine of 1. Here's our inverse cosine or arc cosine cheat sheet. We're trying to figure out where is cosine 1. And here it is. That's out 0 degrees or 0 radians. Your answer here is 0. That's it. Let's go on to number 9. Example 9, parentheses first. Let's find inverse cosine of √3/2. Here's your arc cosine cheat sheet. Where's our cosine value? √3/2. Is that what it was? Yeah. That's where cosine is √3/2. That's at pi/6 radians. So this inside the parentheses simplifies to pi/6. Cosecant pi/6. Okay, so here's what we now have to do. We want to go back to pi/6 radians. Here, we're looking for the cosecant value. Well, in order to find the cosecant value, we have to remember, well, what is the reciprocal of cosecant? And that is sine. Very good, sine, yeah. So our sine value at pi/6 radians is 1/2. And what is the reciprocal of 1/2? 2. Your answer is 2. 10, write the equation of a sine function that has a given characteristics. amplitude of 5. Amplitude goes in front of your trig function. Period of 8 pi. So we need to do 2 pi over b is equal to the new period. This right here will simplify to 1/4. So our b value is 1/4. We need a 1/4 in front of our x value. That's the only one. Okay. 11, write the equation of a sine function that has given characteristics. Man, I hope we have a lot of these on our next test. These really aren't too bad. At least I don't think so, but I get paid to do this. Write the equation of a sine function that has given characteristics. Amplitude of 5. We just got to figure out what value goes in front of x here. It has given us a period of 6. 2 pi over b. Set that equal to 6 or 6 over 1. Let's multiply. B times 6. Divide away the 6. For a final answer of 1/3 pi. So 1/3 pi go in front of our x. Or pi over 3, same thing. There it is. Well, find the exact value. Do not use a calculator. Tangent of pi. Tangent, that's the regular unit circle. There is pi. What is the tangency value at pi? 0. Example 13, we need to take this function, find the period. In order to find a new period, that formula is 2 pi over b. In this case, our b value, the number in front of x, is going to be 3. So we just substitute 2 pi over 3. Simplify if you can, but you can't. Final answer. 14, inverse cosine of -1/2. So we want to make sure we're using our inverse cosine or arc cosine cheat sheet. We want to find the cosine value that is -1/2. There it is. That's where cosine is -1/2. That occurs at 2 pi over 3 radians. So that would be our answer there. 2 pi over 3. Is that what it wanted us to do? So we'll put it 2 pi. Select the correct choice and fill in any answer boxes in the end. Okay. Oh, so you got your answer here. 2 pi over 3. 15, determine the amplitude, period, and vertical translation at any phase shift of the given graph. So our amplitude is going to be 4. That's the number in front of your trig function. The period is, what's our number in front of x? What do you think? I don't see a number. So it's 1. And 2 pi over 1 is 2 pi. When there's no number in front of x, your period is going to be 2 pi. Well, as long as it's the cosine or sine wave. Does anybody remember what your period is if it's a tangent function? It's not 2 pi. It's just pi. It's pi. Now we're talking about regular parent tangent, not inverse tangent. All right, let's see. The vertical translation is, there is nothing there outside to the right. Phase shift. This number here is going to be your phase shift. It's going to be opposite of what you think it would be. Not left, pi over 2, but right, pi over 2.
So on the review,
we are now needing to match an equation with a graph. Let's see. Like I said, let's see if we have any sort of vertical translation here. We don't. So our graph should be symmetrical at y equals 0. No, not there. So we can cross that out. Yeah, maybe that one. Maybe that one. Definitely not that one. So we've narrowed it down to 2 possible options. We have an amplitude of 3. Remember, positive 3, not negative 3. 1, 2, 3. There would be our top bumper. 1, 2, 3. There's our bottom bumper. All right. 1, 2, 3. 1, 2, 3. Darn. Both of these have an amplitude of 3. Let's see here. We have a phase shift left, pi over 2. This is a sine wave. Remember what the pattern is? Middle, up, middle, down, middle. But we have a reflection, so that means your arrows are going to change direction. Okay, looks like both of these have that phase shift left pi over 2. So let's figure out which one of these has this given pattern. This one starts middle, up, middle, down. Not that one. Middle, down, middle, up, middle, down. That one follows the pattern. So it's got to be C. 17, use transformations to graph the function. Once again, no vertical transformations. So we should be symmetrical at y equals 0. Our midline should be going through y equals 0. Not that one. Possibly. Possibly. Not that one. Amplitude of 2. 1, 2. 1, 2. Where is it? 1, 2. Yeah. Okay. Both of these have that has an amplitude of 2. 1, 2. 1, 2. Also has an amplitude of 2. Sine wave. Here's the pattern. Middle, up, middle, down, middle. No phase shift. So I'm looking at the y-axis and seeing which of these graphs start right here at the middle. Well, not that one. This one does. Middle, up, middle, down, middle. It's got to be C. Are all of these C? Without graphing the function, determine its amplitude or period as requested. Find the period. Oh, thank goodness. These are so much easier. Find the period of the function y equals 3 times cosine of x. Remember, to find period, it's 2 pi over b. Our b value here, the number in front of x. There is no number visually that we can see. So it's 1. And 2 pi over 1 is 2 pi. That's your period. 19, match the given function to its graph. Oh, we got a lot going on here. Okay. Well, at least we don't have any phase shifts. Sine. The pattern is middle, up, middle, down, middle. Cosine, the pattern is up, middle, down, middle. It appears that this has an amplitude of 1, this has an amplitude of 3, this has an amplitude of 3, this has an amplitude of 1. So I'm going to, let's work with my amplitudes of 3 first. Which of these graphs have amplitudes of 3? These two. Up 3, down 3. Up 3, down 3. So these two graphs must go with these two functions here because those are the only ones that have amplitudes of 3. Well, one's a cosine wave, one's a sine wave, so we just have to figure out which one matches our pattern. This one starts middle, up, middle, down, middle. That's sine wave. So 3 must go with C. 3C, 3D. Get rid of that one. 3C, 3C. Okay. Therefore, this one must go with D. So 2 and D, 2 and D, 2 and D. Oops, you don't have a 2 and D, so you're out of here. We've already matched this graph. We've matched this graph. That one, that one. Okay, looks like for our sine and cosine, both of them have an amplitude of 1. These are the only two available options we have left. So let's just figure out which one of them matches a pattern of sine wave or cosine wave. Looking at my y-axis here, this one starts up, middle, down, middle, up. So this one is a cosine wave. So 4 goes with A. 4A. That's not 4A. Boom. Your answer is A. Example 20. They want us to find the amplitude. The amplitude is the absolute value of the number in front of your trig function. The absolute value of -3 is 3. Done. 21, find the exact value of the expression. So parentheses first, we got to solve what's in here. Sine 7 pi over 6. Regular unit circle. Where is 7 pi over 6? There. What's the sine value? -1/2. So all of this in parentheses simplifies to -1. Now we're doing inverse cosine, so get rid of this. You need that. Here's our inverse cosine cheat sheet. We got to figure out where is cosine -1/2. There's where cosine is -1/2. That occurs at 2 pi over 3 radians. Boom. 22, without graphing the function, without graphing the function, determine its amplitude period as requested. The function will find the amplitude. Yes. That's it. It's just 3. These are easy. 23. Find the equation of the graph. See, here's what I would do. I would locate your top and bottom bumpers. Looks like we have a top bumper at 2 and -2. Therefore, our midline is going to occur right in between them. So there, we have no vertical shift, which I don't think is going to help us too much narrowing it down. All of these functions have an amplitude of 2, so I'm just kind of wasting my time there. Sorry, and y'all's time. It looks like the only thing that's going to help us, at least to start off with, is we have cosine and sine waves. Let's figure out what the pattern is. Middle. We're starting in the middle, so this must be a sine wave. Bye-bye cosine. Bye-bye cosine. Middle, down, middle. So we have a reflection. Both of these have a reflection, so that's not helping us. We haven't completed a full cycle here. So remember, this is middle, down, middle, up, middle. This is where it would complete the full cycle. So let's figure out what is our period that we're dealing with in this graph. So what I'm going to do is I'm going to take 2 pi over b, but instead of b, I'm going to pick, you could pick either this one, 1/3, or this one, 3 to use. It doesn't matter. I'm going to pick 1/3. Now I'm going to simplify. All right, so the period of this function is 6 pi. Remember, this pattern, middle, down, middle, up, middle. This would be 6 pi here. What's our halfway point of 6 pi? You know what it is? 3 pi. Halfway through a sine function is going to be at this point here. This, complete it, hang on. This is halfway. That is a full period. So if our halfway point of 6 pi is 3 pi, then this graph should stop at 3 pi, which it does. Middle, down, middle. We're at the halfway point. This function right here is 6 pi, meaning its halfway point should be at 3 pi, and it is. So that is your final answer. Example 24. A. The answer was, wait, did you say 24 or 23? The answer is A. Okay, F inverse. This is the one we're not doing. Thank you. Thank y'all. Man, y'all are really good. Skip this one if you're working along at home. Good job. Determine whether the proposition is true or false for y equals 3 times sine of pi of x. The amplitude is 3. That's true. And the period is pi over 2. Let's see. 2 pi over, what's the number in front of x? Pi. What does that simplify to? 2. So true or false? False. Very good. Very good. Mr. Ventura. Very good. I believe you solved the case. If you know that movie, I'll give you a pack of gum. You got to answer in 10 seconds. Very good. Very good. I believe you solved the case. Time's up. No, it was Ace Ventura 2. When Nature Calls. Oh my gosh, I'm still recording. Find the exact value of the following expression. Inverse sine root 3 over 2. Inverse sine. So we're going to use our arc sine cheat sheet. We want to find out where is sine root 3 over 2. Here. That occurs at pi over 3 radians. That answer is pi over 3. Very good. Boom. Find the equation of the graph. Oh, good. These have amplitudes of 3. These have amplitudes of 2. Let's figure out what the amplitude of this graph is. 1, 2, 3. 1, 2, 3. Your amplitude is 3. Bye-bye amplitudes of 2. Both of these are cosine waves. This is a cosine wave. Up, middle, down, middle. Up, middle, down, middle, up. Well, we're going to do what we did. I can't remember for what number it was. I think it was 23. Let's figure out what the period is of this function here. So I'm going to take 2 pi over 2. That equals pi. So what that means is if this is our answer, that this pattern up, middle, down, middle, up, when it gets to this point here, we should be at pi. Let's see. Up, middle. Where am I currently at when I'm at middle? I'm at pi. So is this one the answer? No! How about no? It's B. Holiday Hoobie White. That wasn't good. Okay. Are they ever going to give us a vertical change? I don't think they are. Okay. There is no vertical shift up or down, so your midline is 0. So we should be symmetrical at the y-axis. This one is not. That one looks like it is. That one looks like it is. That one is not. If this one is C, I'm going to scream in turn so as to not frighten anybody. I'm getting some head nods. Thank you. Is it C again? You're right. It's C again. You know what? I hope y'all's next test is like this. That would be nice. It's C again. Yes. Yes, it would. All right, it's C again. This is a cosine wave. That pattern is up, middle, down, middle, up. This one starts middle, down, middle. 29. All of these have an amplitude of 3. All of these are cosine. These 3 are reflected. This one is not. This one starts down, middle, up, middle, down. We have completed one full cycle. This is reflected. Remember, cosines usually start up middle. This one starts down. So we can get rid of this one. I think what's going to help us is let's figure out what's our period. Hey. Oh, that says sine. We can eliminate that one. Boom, get out of here. So I'm going to take, I could either take 1/3, I could take 3, doesn't matter. I'm going to take 1/3 and figure out what is the period. So 2 pi over 1/3, that's the same thing as 2 pi times 3, which is 6 pi. So this function here has a period of 6 pi. What that means is once we complete the cycle, which in this case is middle, is down, middle, up, middle, down. Once we get to this point here, we should be at 6 pi radians. Let's see what happens. Down, middle, up, middle, down. We should be at 6 pi radians. We are at 6 pi radians, so it has to be B. For what numbers of x? I hope y'all are paying attention. For what numbers of x is 0 less than or equal to x, and x is less than or equal to 2 pi? Oh, okay. So from 0 all the way to 2 pi, and it can include 2 pi. Sine of x equal to 0. So that is not an inverse. So we want to use the regular unit circle, and we want to figure out where are all of the sine values 0, starting at 0 radians. Well, there's one. So we could say 0. Let's go around to pi radians. There's our sine value at 0 again. And if we go all the way around the unit circle, we will have accomplished 2 pi radians, and we have a sine value of 0 there too. So your answer is this one. Not labeled A, B, C, or D. Oh. Find the equation for the graph. That's too many options. This one starts, oh good, no phase shifts. This one starts middle. We're looking at the y-axis to determine our starting point. Since there is no phase shift, we're starting middle, so that is a sine wave by cosine, by cosine, by cosine. We've narrowed it down to 3 possibilities. Now remember, sine waves go middle up. This one goes middle down. So we must have a reflection. This one is not reflected. Bye-bye. We've narrowed it down to these 2 possibilities. What is our amplitude here of this graph? It's 1. So should there be a number in front of our trig function? No, there should not be a number in front of your trig function. If there's a number in front of your trig function, that means your amplitude is something other than 1. So it has to be this one, D. Okay, for example 32, be really careful with this one. This says inverse tangent of 0. So we have to use the arc tangent cheat sheet. Now there is only one value, or 1 degree, 1 radian, where we have a tangency of 0 on our arc tangent cheat sheet. And that's here, okay? I ran out of room. Your cosine is 1, your sine is 0, your tangency is 0. That occurs at 0 degrees or 0 radians. You may be thinking to yourself, well, what about 2 pi? If we go all the way around the unit circle, we will have achieved 2 pi radians. That also has a tangency of 0. You're right, but we're dealing with inverse tangent or arc tangent. Remember, there's a restriction. We had to restrict the domain. If we were to do 2 pi radians, we would have to go through a restricted region. You can't do that, which is why 2 pi is not an answer when we're dealing with our inverse tangent. Okay, for 33, find the period of the function. Here is the value in front of x. So 2 pi over negative 8 pi over 7. That's the same thing as 2 pi divided by 7, which is the same thing. Yeah. Let's keep, change, flip. Now what I'm going to do here is I'm going to multiply numerator times numerator. 2 times 7 is 14, carry over the pi, over negative 8 pi, and reduce. Those cancel. 2 goes into 14 7 times. 2 goes into 8 4 times. Don't forget the negative. Does it not have a negative root? Doesn't have a negative. That's weird. Well, that one looks like the closest one. Keep 7 over 4. There was no negative there. Find the exact value of the expression. We have to solve this portion first. Inverse cosine negative 1/2. This is where cosine is negative 1/2. That occurs at 2 pi over 3 radians. So now we have to find the tangency at 2 pi over 3 radians. 2 pi over 3 radians, that tangency is negative root 3. Let's see here. Once if this C again. There is no vertical transformation, so our graph should be symmetrical at y equals 0. Symmetrical? No. Symmetrical? No. Sine, that pattern is middle, up, middle, down, middle, but we have a reflection, so it was going to change to middle, down, middle, up, middle. This one follows that pattern, middle, down, middle, up, middle. Got to be A. Thank goodness. Wasn't C this time. Find the exact value of the following expression. Inverse tangent of root 3. Arctangent cheat sheet. Where is our tangency root 3? Right there. That occurs at pi over 3 radians. Find the amplitude. Yes. Yes. Remember, the amplitude is the absolute value of your A term, which is going to be the number in front of your trig function. The absolute value of negative 2 is positive 2.
Can this just be all those button long steps? And then find the end.
Right? Wouldn't that be great? I hope that there's as many on the test as there are in the review. That'd be great. I even think the matching ones are pretty easy too. You can normally eliminate 2 right off the bat. And then you can just remember the patterns, you should be fine. Another matching. Matching function. Once again, no vertical transformation, so we should be symmetrical. All of these are symmetrical. Wow. Okay, they're throwing us off. Amplitude of 3. 1, 2, 3, 4. That has an amplitude of 4. No. 1, 2, 3. 2. Bottom bumper. Maybe that one.
Is it possible that I could?
Can't you see I'm going through my routine right now? 1, 2, 3. 1, 2, 3. This has an amplitude. 1, 2, 3. Yeah. Top and bottom bumpers at 3. 2, 3, 4. Okay, this one has an amplitude 4, so that one's not it. It has to be either B or C. Oh, good. Sine wave. That pattern is middle, up, middle, down, middle, middle, up, middle. That one starts at the top. Can't be down. It's B. Man, I hope this is like y'all's test. Find the equation for the graph. Middle, up, middle, down, middle. That is a sine wave, no reflection. Darn it! All of those are sine waves with no reflection. Amplitude though. 1, 2, 3, 4, 5. Top bumper. Negative 2, 3, 4, 5. Bottom bumper. Amplitude of 5. Okay, I'm going to take 2 here and figure out what the period is. 2 pi over 2 for a period of pi. So what that means is our pattern should go middle, up, middle, down, middle. And if this one is the answer, then once we get to this point of the pattern here, we should be at pi radians. Middle, up, middle, down, middle, we're at pi radians. Therefore, your answer is B. Hold it. Today's best match is the graph. Well, it looks like we have an amplitude of 1, 2, 3, 4. 1, 2, 3, 4. Yep, amplitude of 4. Get out of here, 2. This one starts top, middle, down, middle, top. This is where the cycle ends. Top, middle, down, middle, top. Right there. So don't be thinking, oh my goodness, our period is 2 pi. It's not. This is a cosine wave. We started, yes. So we can get rid of sine. We just now have to figure out, well, which one of these has the correct period that matches this particular function. So 2 pi over, I'll just pick this one. Take that 2, substitute it here to get pi. So that means our graph should follow this pattern: up, middle, down, middle, up. Once we get to this portion of the cycle here, we should be at pi radians. Up, middle, down, middle, up. Is this pi radians? Well, it looks like our scale is 2 pi. This is halfway. Half of 2 pi is pi. So it's got to be this one. Write the equation to sine y equals 5 sine. So we can go ahead and eliminate that one and that one. Period of 3 pi. So we want to take 2 pi over b, set equal to the period. 3 pi over 1, cross multiply. Divide. So there should be a 2/3 in front of our x value. It's got to be that one. 42, complete the sentence below. The function y equals 5 cosine has an amplitude of 5 and a period of, well, I don't know, let's see. 2 pi over 4, which is pi over 2. The function 5 cosine 4x has an amplitude of what? Is it the exact same thing? Oh. What do they find the exact value of the following expression? Inverse sine of √3 over 2. There's our arc sine cheat sheet. What does it want to know? √3 over 2. So we're going to find the sine value. Where's sine √3 over 2? There. How many radians is that? Pi over 3. Inverse sine, -1/2. So we need arc sine cheat sheet once again. Where is our sine value -1/2? Right there. That's at, what was it again? Negative pi over 6. That's what I thought you said. Good job. Negative pi over 6 radians. Have a good weekend.